Okay. Okay, so the last thing, like I said, that'll be covered on the quiz is properties. Okay, properties. Now, there are a list of properties here, okay, that involve um, integrals, integration, area under the curve. Okay, so when I say integrals, integration, that just means area under the curve. Okay, now the thing about using properties is that there's not a lot of calculations, right? It's either you recognize the property or you don't recognize the property. So um, that's why I spend at least a day, probably even 2 days looking at this. Okay. So sum and difference. We've talked about that one before. You can break. So if you have one function plus another function and you're finding area under the curve and they have the same bounds, right? They have the same bounds. You can break them up. And then if you were adding or subtracting them before, you just do the same thing as you were doing. Okay, we've talked about that one before. Constant multiple, we might have talked about that one. If you have a constant, not a variable, a constant times a function, you can move the constant out in front. Okay. This one we haven't talked about. It's called reversal interval, right? The lower bound always needs to be on the bottom. The upper bound always needs to be the higher. But what will happen sometimes is that'll be reversed. So let me give you an example here. So if we're finding bounds, I'm going from 0 to 4, right? The lower one should always be a smaller number than the higher one because we always go to the right. But sometimes what they'll do is they'll reverse that. When they give you the problem, they'll say find this area. Oops. Is there a delay there? There we go. Okay, so sometimes they'll do that. They'll say go from 4 to 0. We're not going backwards. You can't go backwards. You can't go left, right? You can't start at 4 and then go left to 0. That doesn't work for integration. You always have to start at the bottom and go to the right. So if that's not correct, if that ain't correct, you can change it using reversal interval. I can change it. To 0 to 4 to reverse them. The only stipulation is that the only thing you need to put a negative out in front now. Okay, so if you want to reverse them, you can. You just have to put a negative out in front or a -1 out in front. Okay, so that's the first thing you always do when you're looking at bounds. Should they be reversed? Or does it go from low to high? Okay, the bottom should be the low, top should be the high. Always, always, always. If it's not, do that. First thing you do that, and then go about your process. So whatever answer you get, it's just going to be an opposite sign. This one's the 0 length. It's pretty obvious. If your bounds are the same, like if you go from the same spot to the same spot, it doesn't really matter what the function is. Your area, you're not going to have any area, right? Because if I say, for example, draw a picture here. If I go from A to A, right? If I go from A to A, I'm not going anywhere. I'm just going up, right? So all you're finding is area of a line. And by definition, a line has no area. Doesn't have any width. Line doesn't have any width. Has length, but it doesn't have any width. Okay, so that one's there. Adding intervals. This is the one we're going to use today. So if you look at, this one's saying if I go from A to B, and then I add on B to C, they share B, right? B is the ending here, but it's the starting here, right? It's the same as just going from A to C. Okay, common sense, but you'll see that a lot. That's the one, we're going to see this one quite a bit today. This one we're going to see quite a bit, and this one we're going to see quite a bit because those are the new ones. Everything else you guys have seen before. Okay, Also, remember, this is not on there, but remember this from yesterday. Let me show you this. It's not really it's not a property, so that's why I didn't put it on here. But let's say we have this. Let's say we have something from A to B. Okay, that's the original. And then let's say I do this. What is that going to do to the original function? I change this. Let me change a different color so it stands out a little bit. What is that going to do to the original function? How is it going to affect the function from A to B? It's going to move it up 4, right? It's going to move it up 4, so it's going to create new area, right? New area, because as it moves up, it's going to become more positive, so it's going to create a bigger area than this guy, right? If I do this, oops, what is it going to do to the function? Move it down 4. So we're going to have less area, okay? Less area. All right, now what about this? What if I do that? It's going to move to the left, yeah. Everything's going to shift to the left, right? Everything's going to shift to the left 4 units, okay? And then same thing if I do this, or not the same thing, but same idea, right? If I go this, everything's going to shift to the right 4 units, okay? So sometimes what they'll do is they'll do this. You'll see something like this. Plus 4, 1/2. What is that function? How do I tackle this guy here? How do I tackle this guy here? This is more, I've seen this question on a free response question on a test where they wanted you to find area. They didn't use A to B, but they used numbers. But this was it. They had 1/2 f of x plus 4. The function's gonna, so the x plus 4, right? We move to the left 4. Okay, so everything's moving left 4. Okay, got that. What do I do with the 1/2? So this is what you can do. There's 2 ways you can handle the 1/2. 1/2 you can handle, every y gets cut in half. So if a y was at 10, now it's at 5. That's one way you can do it. That's a little more complicated. The way I would do it is just move it to the front. And then once you find area of this guy here, multiply by 1/2. It's really just halving the area. That half means whatever area was there before is now become half as big. Okay? Or if it was a whole number, it would double, triple, whatever it is. Okay? So don't freak out if you see things like that. Just know that, okay, so what do I do with the number in front? I can move it to the front. What is that plus 4, whatever number? That means it shifts, okay? Because like today, the nice thing about today is there's not a lot of calculations. We're not calculating a lot of things. But the hard thing is recognizing what property you're going to use and how to do all that stuff, okay? All right, okay, so let's look at the first example. So when they want you to use properties, they'll always give you a given. They'll either give you a picture or they'll tell you what's going on. There'll always be a given, right? So the given here is here. The area from 2 to 6 for a function is 10, I already did it. They already found it. It's 10. And the area from 2 to 6 for another function, same bounds but different function, is -2. Okay? Find the following. So 2 to 6, so A has 2 to 6, right? It's the same bounds, right? It's the same bounds as these guys. It wants me to add them together. Okay, well, we have a property like that. The sum and difference property, right? Says instead of adding or subtracting them together, how about I split them up because they have the same bounds? Okay, it only works if they have the same bounds. So instead of that, let's do this. 2 to 6 for f of x dx, and then add that with 2 to 6 g of x dx. Okay? Now I know what each of them is. This guy right here is the same as this guy right here. All right, and I know that's 10 plus, and then this guy right here is the same as this guy right here, which I know is -2. So add them together, you get +8. Okay. All right, so do B. Yep, -12. Okay. So if it would have been f of x minus g of x, it would have been 10 minus a -2, which would have made it positive, right? All righty. Okay. B and D the same? They might be. Okay, so C. So what this means is the area from 2 to 6, right? We know what the area from 2 to 6 is. They told us at the top, right? They told us at the prompt. I think it's 10. The 3 in front means one of two different things. It means we're tripling the area. Area has been tripled. Find the area under the curve. Or you could just move the 3 out in front. What I do is I don't even worry about that 3. I just put the 3 out in front, find the area, then multiply. 2 to 6 f of x dx. So we know from the prompt that 2 to 6 f of x, that area is 10. So we're just going to go 3 times 10, and the area is 30. That's all that 3 is doing. It's just tripling what the original area was. If it was a fraction, it'd be cutting the area in half and third, whatever it is. Okay? I think D is the same as B. Does it look different? I think it's the same. I think it got just printed twice. So we'll skip D since it's the same as B. Okay. All right, example number 2 then. Example number 2. So now we have different bounds, different areas, still 10. The first one's still 10, but it's different bounds, different functions, okay? So now from 0 to 5. From 0 to 5 is 10 for f of x. From 5 to 7 for the same guy is 3, okay? Answer these questions. Now, some people can see it. Oh, it's stopping at 5, continuing, going to 7. Some people can see that. Some people can't see it. I understand it. I understand both. People who see it, people who don't. So this is what I do. You might not do this, but it helps me. I draw a picture. I draw a picture, just like I did yesterday. And I draw a picture of what's given. Okay? 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. So from 0 to 5, I have no idea what the function is. Is it quadratic? Is it a cubic? I have no idea what it is, but I just know that the area under that curve is 10. So it's got to be some positive. Might be some negative, but it's got to be at least some positive. So from 0 to 7, or from, sorry, 0 to 5. I don't know what it looks like. I'll just guess it looks like that. Right? That area is 10. That's what it says. And then from 5 to 7, so starting at 5 and ending at 7, for the same function, not a different function, the same function, it's 3. So let's say something like that. Again, some of you saw it from the very beginning, some of you might not have. But once you draw that picture, everyone can see it now. What's the answer to A going to be? What's the answer to A going to be? 13, yeah, 13. It's pretty obvious to see once you see the picture. Oh, okay. Again, sometimes it's hard. I know some of you are like, well, why do you draw the picture? You saw it like that. Yeah, but not everyone sees it immediately. Okay, so if you don't see it immediately for these guys, sometimes it helps to draw a picture. Okay, because then you'll see something. You'll see it. Okay, so 13. 0 to 5, or sorry, 5 to 0. 5 to 0. What's wrong with this problem for B? What's wrong with the problem for B? Yeah, the bounds are off, right? 5 is bigger than 0. We can't do a problem. You can't do a problem. You can't start a problem if the bounds are off. So the first thing we got to do is switch the bounds. Well, we can do that. We can do that. 0, 5, right? All we have to do is put a negative out in front. So whatever answer we get, we just change the sign. Okay? So from 0 to 5, we see that it is 10. So therefore, the answer is negative 10. Okay? So sometimes you see the bounds get flipped like that, or the bounds are off. It's not a big fix to do that. You just got to do it before you can do anything. You really can't do anything. I can't do anything until I flip the bounds. All right, so C and D. Do C and D. Same guy. It goes with the same prompt. Okay. So C goes from 5 to 5. So there is no area. So 0. D, you get the 3 in the front. That means you're just tripling it. Okay, so area of f of x from 0 to 5 is 10. So just triple it, you get 30. Okay. All right. Okay, so now example number 3. So now they're giving us, the given is a picture. The given is a picture and not written in integral form. Okay. Okay, so here we go. The regions A, B, C, and D in the figure are bounded by the graph of the function f and the x-axis. Okay. The areas of each enclosed region are labeled with their respective numerical values. So they've already found area under the curve. So this is 15 right here. This is 9. This is 15. And this is 5. They've already found area under the curve for us. So they want to know what is the value of negative 6 to 3. Negative 6 to 3. Okay. Let's see. Negative 6 is right here. 3 is right here. Anything under is a negative, right? So 15 is going to be negative. 5 is going to be negative. So we got negative 15 plus 9 plus negative 5. So what is that? Negative 20 plus 5, you get negative 11. That's f of x. But it's got a 5 in front, right? So you got to move the 5 out in front. So when I move the 5 out in front, that triples whatever answer I get. Or sorry, not triples, 5 times whatever answer I get. So multiply it times 5, and we get negative 55. So what it does, what that 5 does, is it takes every y value and multiplies it times 5. So for example, I'll pick up dot right here. See this dot right here? Negative 1, 4. If I were to multiply that times 5, that would be way up here at 20, right? Same thing down here. This guy here, negative 3, negative 6. If I were to multiply that times 5, it wouldn't be negative 3, negative 6. It would be negative 3, negative 30, right? So it's causing the negatives to get bigger and it's causing the positives to get bigger as well. That's why your number is bigger, okay? A bigger negative or a bigger positive. All right. Example 4. Okay, same thing. Area under the curve. Okay. So they want us to find area from negative 6 to 4. F of x minus 1 dx. Okay, so let's go find negative 6 and let's go find positive 4. Negative 6 is right here. Positive 4 is right here. Okay. There's 2 ways to do this. What does that negative 1 mean? What is that negative 1 here? I'm talking about, when I say negative 1, I mean this guy right here. What does that mean? Hmm? Not to the right, you're close. If it was inside the parentheses, you'd be right. It's moving down 1. Every dot on there, every dot. So every dot that you see here, everything on that little thing there is moving down 1 unit. Is moving down 1 unit. Okay. So how do I do that? What are my steps going to be to figure out how much area under the curve? How do you think I'm going to do that? Any ideas? Because if I were to move everything down one, this, if I were to move up every point right here, right? Every point along this graph here, down one unit. This wouldn't be 9 anymore, right? It would be less than 9. What would it be exactly? I have no idea, but it would be less than 9. This guy here wouldn't be 9 either. It would be less than 9, right? Or sorry, it would be more than 9. Sorry, these two would get bigger by a little bit, right? And then the 4 is not in our bounds, but it would get smaller as well. So how much smaller and how much bigger? No clue. So what do you think I'm going to do? I'll give you a hint. Take a look at this. And think of the properties. What do you think I'm going to do? I'm going to be a hint. I'm going to use one of the properties. Which one do you think I'm going to use? There you go. I'm going to use the sum and difference rule, right? It's really the only one I can use because I have a difference here. And they're all under the same bounds, right? They all go from -6 to 4, right? So I'm going to break it up into 2. Okay, so let's see. So the first one, -6 to 4 for f of x dx. Okay. Minus from -6 to 4 for +1 dx. +1 since I use the minus in front. Okay, so I have 2 things now. I have this guy here, and I have this guy here. I'm not worried about the one to the right. Let's do the one to the left first. That one's just the basic, right? That one's just the basic area under the curve from -6 to 4 for that guy there, right? So it's -9 plus 9 minus 8. -9 plus 9 minus 8, which is -8. All right. Done with that guy. Now, how in the world am I going to do this guy here? Give you a hint. You've done it before. Not today. In the last set of notes, we did this before. Does anyone remember? This page here. Change that to a 1 and change that to -6 and 4. That's the same problem we're doing now, right? This is f of x, our bounds. We drew a picture, we did that. That's exactly what we're going to do. That's why we did this lesson before this lesson today, because I knew we would know this. We would need this, okay? So this guy here was 3, right? This is, yesterday, 2 days ago. I think we did this 2 days ago when we started. So we said the function was 3, right? And we said, what does that look like? what does a function of 3 look like graph-wise? It looks like a horizontal line at 3. And then we said from 2 to 9, and then found the area of that, right? Okay, so let's go back to today's. So let's draw a picture. I don't need to use this graph here. I don't need to use this graph here. Why do I not need to use this graph for this part? Is because there's no f of x. There's no f of x here, right? This one had an f of x, so I had to refer to the graph. This one doesn't. This one's just 1, right? So let me draw a picture. From -6 to 4. So from -6 to +4. What is this guy going to look like when I draw it? Hmm? Yeah. So what is the 1 look like? So you're already a step ahead. So what if I graph the function 1? What is that going to look like? A line, vertical or horizontal line, where y equals 1, right? Which turns into a rectangle, right? All above the x-axis. So we find the area of that rectangle. This is 10. It is 1 unit tall. We get 10. So -8 plus 10 equals 2. Oh, sorry. Yep, subtract. So you get -18. Yep, -18. So you can see what moving everything down 1 unit would do. Without moving everything 1 unit, without touching the thing, you get from -6 to 4, you get -8, right? So it's already negative, more negative. If I move everything down, it's gonna increase the area by 10 negative units, right? And that's what we said. Everything's gonna get smaller, right? The positives are gonna get smaller, the negatives are gonna get smaller, but bigger negatives. Okay. All right. So sometimes, like I said,
Because when I looked at it, like I immediately just thought it was a normal, you plug in f of x and
subtract. So when you say plug in, what are you talking about when you say plug in?
so like when you find f of x,
Uh huh.
you
You talk about the dots. You talk when you the points, each point,
yeah,
and then you subtract 1.
yeah, that's what I thought. I'm just confused on how you know when to.
That's a great question. So that's what it's doing, right? That's what it's doing. It's taking all of these dots, taking all of these guys here, right? All of these dots, right? Let's see. Let me make some more dots here. So let's see, like this dot. There's infinite number of dots, right? But it's taking all of these dots and it's moving them down to 1 unit, right? It is. It's moving them down 1 unit. It's subtracting 1 from the y. So this dot right here is no longer, this dot right here is no longer -1, 4 anymore. It's going to be -1, 3, right? So it's going to be right here, right? So we can do that, absolutely. The problem is when we draw our new shape's going to look like this. It'll kind of look, everything's going to be down 1 unit, so it'll kind of look like this. The yellow is getting smaller and the purple is getting bigger, right? We see that, right? We see that. I don't have a way to calculate those exactly. That's why you can't do it that way. Because once I knew that The yellow would get smaller because all of these dots right here would go down one, go down one, go down one, go down one, and then the purple would get bigger. The areas of purple would get bigger, but I just had no way of calculating it exactly. I had no way. So the only way to do that was to go back here and use the property. Yeah. In the future, you'll have other ways. But as of right now, we don't have any other ways. When we don't have any other ways, that's the only way we can do it. Yeah. In the future, I'll give you more ways to do it. But as of today, that's the only way. Yeah. Okay. All right. What do we got here? Okay. Okay. So do number 5. I'll let you guys play with number 5. Do number 5. Example number 5. Give you guys a few minutes to do that one. Okay, so just so that we don't run out of time here, so we finish this problem. I drew a picture. Now, is this picture to scale? Absolutely not. It's not to scale. But I just need something visual to see because they told me, okay, from -3 to +3, you have a function with an area of +5. Now, is it all positive? I don't know. Some of it might be negative, some might be positive. I don't know. But I know that the area is 5. Oh, yeah, you're right. Yeah. Yep, you're right. I labeled it wrong. Yep. Oops. Okay, so, and then the whole thing plus a little extra piece, if I added the yellow and the green together, that whole thing is going to be -2. So I just assumed, okay, that it's a pretty safe assumption that there's going to be some negatives here. If it goes from, if the green is positive and then I include the yellow in there and it turns negative, that there's going to be some negative area. So the whole area combined is -2. Okay. So it gives me a picture. It might help, might not help, but it's a place to start. Then the question says, okay, so from -6 to -3, so only this yellow area. What if you were to take the original and move every dot down 2? Every dot down 2 units. Well, first of all, do I know where any of these dots were from -6 to -3? Do I know anywhere? It didn't give me a graph. It didn't tell me what f of x was. So I'm guessing here where the dots were. So I can't even subtract, right? I can't even lower the dots by -2 because I didn't even have a place to start out with. Subtract 2 from where, right? So like at least the last problem, I knew where because they gave me a graph, right? The last problem, they gave me an actual picture to look at. Here they didn't. They said some generic thing. So I have none of that. So all I have is the given and this part here. Okay? The question. So I can't subtract 2 from what? From, they didn't give me that. So now my only option is to use the sum and difference rule. Okay? So I go from -6 to -3 for f of x dx minus, and then I go -6 to -3 for 2 dx. When I break it up like that, the first part I can do because it told me from -6 to -3 is, it didn't actually tell me. What is from -6? What is this guy here going to be? They didn't tell me that, but I can figure it out. How do I figure out what -6 to -3 is going to be? They didn't tell me, but I have enough information where I can figure it out. -6 to -3 is just the yellow. How much area is in the yellow? That's what it's asking. So how do I figure out what area is just in the yellow? Yeah, exactly. I know how much the whole is, right? From -6 to 3, the whole thing is -2, right? The whole thing is -2. And I have part of that, right? The green, -3 to -5. Or sorry, -3 to +3. So how do I find the green? Take the whole minus the piece, and you have the piece left over, right? All right. So what do you get? What's the whole minus the piece? -7, yeah. -7. The whole area is -2. This piece is 5. -7. Okay. This right here. Again, it's going to create this picture here. Again, we're not talking about f of x, so you don't got to worry about f of x anymore. -6 to -3. It's going to be at 2. Straight line. Area here. Let's see, that's a 3 by 2 rectangle, which is +6. So you get -7 minus 6 equals -13. This guy is -13. Okay. Okay, so tomorrow we'll finish these out, and then I'll give you some more practice. We'll finish this in class, and then you can start on your assignment tomorrow. Okay. Alrighty.